Greetings and welcome to the Alliance BioEnergy Plus Inc. webinar. It is now my pleasure to introduce your host, Ben Slager, Chief Executive Officer. Thank you, Mr. Slager. You may begin.
Thank you, Keith. Welcome, ladies and gentlemen. Thanks for the opportunity to present our company in this setting. I would suggest that I will summarize our presentation, our position in the market, and then give you, ladies and gentlemen, the opportunity to ask questions. So Alliance BioEnergy Plus is a company who has developed a technology, an improved technology compared to what it had before, to convert cellulosic material into sugars. Those sugars can subsequently be fermented into ethanol. This ethanol is qualified as cellulosic ethanol and can be used in fuels, which is done now similarly with the corn ethanol, as most of you know. The huge difference between corn ethanol and cellulosic ethanol is multifold. First of all, financially, we have a much more cost-effective process leading to our cellulosic ethanol. Our target cost price is about $1 a gallon. Corn ethanol cannot reach that. A second very big advantage is, for example, corn, which can be used for food, is generating about 600 gallons per acre per year, where an energy crop which we could use as a feedstock, for example, cane grass, in combination with our process, would lead to 3,000 gallons per acre per year. So that is way more effective. Another very big distinctive difference between the corn ethanol and the cellulosic ethanol is that we do not have a market cap. To the contrary, we have a mandated volume by the EPA. The mandated volume is 580 million gallons per year, and if the industry does not produce that, it will be fined. The mandate is growing all the time, while the corn ethanol is capped by 10% of the gasoline volume. On top of that, to produce cellulosic ethanol is made very attractive, and it leads to a subsidy of about $1.60 per gallon at this moment, which in the foreseeable future will remain in place. And what we also see is that there is no serious producer of cellulosic ethanol at this time. We feel we have a very strong and competitive process to be able to do it in the next, say, 1.5 to 2 years. We would be able to produce ethanol. We can also convert that ethanol into jet fuel, by the way, and use it as biojet fuel. At this moment, the demand of jet fuel is, of course, a lot lower due to the situation, but that will pick up after things get back to normal. So what is another big difference between our process and existing processes leading to cellulosic ethanol? There are a couple of processes possible to produce cellulosic ethanol. It's an acidic process which is not environmentally friendly. It leads to a very high investment. It leads to dangerous chemicals. We have the enzymatic process, which is not competitive at larger scale. It's too expensive. So if I compare our process to that, we are much more cost competitive and therefore efficient in the market. So we feel that we have an excellent position to build on. So what is our position at this moment in our roadmap forward? We have developed a new, very efficient technology. We have restructured the company, and we are now building towards commercial production. So we just installed the 4th generation prototype. We're going to go through a testing phase for about 3 to 6 months, which will lead us to optimize certain designs, parameters, material choices, and so on to upscale our production to a larger volume. After that, we'll probably go to a commercial volume and to a commercial capacity from there on. Another very interesting side road which we want to follow is that with our conversion of the cellulosic materials into the sugars, we get a byproduct. Basically, we get it free in our process, which is called lignin. That lignin in our process is so valuable because it is chemically unmodified and chemically clean. And that lends itself very well and say chemically well to make bioplastics, but also commercially well. There are other lignin sources available in the industry. However, those lignins are always contaminated with chemicals and or are even chemically modified. So to bring them up to a certain state where they can be used to make plastics is expensive. Not impossible, but expensive to the fact that it doesn't pay off to do it. In our case, we can have a very cost-effective product, and the bioplastic market is a huge market. If we, for example, only look at straws and throwaway utensils, that's an enormous market which we will have our hands full to serve with our bioplastics in the near future, the years to come. So that is basically where we are in our process, what we have as a company, and what we have been doing in the past and what we're going to do in the future. I know it is we don't have much time, and it's basically in a nutshell. But perhaps if anybody has questions, it's a good time to ask them. Maybe Anthony, you can explain a little bit where we are on the stock side and on the financial side and getting audited and so on. I think that is important and of interest of many people listening. And then perhaps we can dig in a little bit more if people have questions.
Sure. The financials are completed through Q2 of 2020. They're in the process of being audited. We have 2.5 years to audit, so it's taking them some time. They have finished auditing the 2018s, moved to the 2019s, so we expect that this will be completed. At the rate they're going, it'll probably take another couple of months to get the 19s and 20s done. But we have a lot of confidence it's going to happen. And then we're going to be listing back to the OTCQB and removing the stop sign that is currently on our stock. As far as shares, people always ask that question. There's about 250 million shares outstanding, and fully diluted, counting warrants, most of which are out of the money, is about 325.
Okay, thanks for that, Anthony. Anything else to add to it?
Maybe we should just go to questions.
Yeah.
Okay. First question is, explain the difference between your technology and the many failed attempts at converting cellulose to fuel in the past.
Okay, well, I touched that a little bit in my previous words, but let me go into that a little bit deeper. So basically, there are two reasons why a technology can fail. First of all, it does work, but it's not economically feasible. And that has happened with most of the technologies. It just takes a lot of effort to separate or to convert the cellulosic material in its base components. It is done through a couple of technologies like steam explosion, the acidic route, the enzyme route, and they all have proved that they either do not work flawlessly, so on a larger scale, because they are chemically oriented, and then I'm looking at enzymes. There are processes where it's a combination of acidic acids and enzymes, where they strip the hemicellulose from the cellulose with the acid, and then have the cellulose being broken down by the enzymes. That's all an extensive process with expensive chemicals. Enzymes are very expensive, and the processes take long and are expensive. If you look at steam explosion, it works, but it requires very high temperatures, very high pressures, so the capex is very high, leading to a cost price which is not sustainable. So we all like green energy, but if push comes to shove, nobody wants to pay a large premium for it, and certainly not in products which are repetitive. If you buy something once, you say, yeah, well, I'll pay a little bit more because it's green. But if you have to fill up your gas tank, and the average citizen in the U.S. has to do that once or twice a week, they're not going to pay a lot more for biofuels. So that is the reason why existing processes have not worked so far. So they either work technically but are too expensive, or do not work technically at all. We have proven already that our process works on modest scale, so I would say on good size scale. It's a mechanical process. We don't have expensive chemicals at all, and we are in the process of upscaling. And what we have seen so far during upscaling is that it gets better instead of less. So that's a very good development, and that gives us full confidence that we are able to do it and upscale to commercial scale. And we are full on that way. We are expanding our team. We are funded sufficiently well. And so there are a lot of things in the green zone. That does not mean that there doesn't have to be a lot of work still done, but it is overviewable. We have a clear roadmap, and we have all the factors in place to get there where we want to be.
Okay, the next question was a couple of questions. You've been working on this technology for years. When will you commercialize production? What is the delay?
Yeah. So, okay, I think that is from the perspective of an investor who has been shareholder for a long time, a very legit and very clear question. Let me try to address that. There are several factors which has caused the delay. First of all, there was a technical inefficiency of the CTS 1.0. When I came in the company, I recognized that the chemistry and the technology behind the chemistry was marvelous and worked very well. The reactor choice which was made proved to be, say, insufficient, not efficient, and that's why the progress made was not enough to get to commercial scale. While doing that, unfortunately, the management at that moment didn't have the interest of the company at heart first. They had other motives and other interests. So unfortunately, they drove the company into a financially very unfavorable position, let me say it politely. So what has been done since I came in on board, say 2.5 years ago, is if I invented a new technology, we developed that new technology up to where we are, onwards to commercialization and a good commercial scale. So we basically started with that a little time after I came in, and we had to reorganize the company completely to get it out of the dire situation financially. And I've done that together with Anthony through a Chapter 11 process that took its time. And why did it take long? Because we chose to keep all the shareholders whole. We could have also followed the route to quickly and hardly chop everything off, and including the shareholders, and then it would have been done in half the time, but everybody would have lost their shares. So we chose not to do that. and we accepted the fact that that caused a longer trajectory, but we have finalized it successfully. So basically, since the end of October last year, we are, between brackets, a new startup with a clean slate financially, with a good technology and efficient technology. Our new technology, the CTS 2.0, is about 2,000 times more energetically efficient than the CTS 1.0. So those two factors has taken its time, and that is why it never turned into something before, because they were missing. We have cleaned it up, and now we are ready to go forward as basically a new startup.
Next question is, with the testing that has been done so far, do you see any problems with scaling up? And when do you anticipate generating revenue?
Yeah, no, I have not. I don't see problems with scaling up. I am positive, and it's a mechanical process, and basically it's a duplication of size, which leads to a higher capacity. When do I expect to be commercially ready to have a reactor on commercial scale? I think that is between 12 and 18 months from now. When do we think we're going to generate revenue? That could be around that same time. We are working on plans to line up starting to get revenue by around 18 months from now. So that is what we expect as a reasonable, straightforward, and solid expectation. I would not want to go into scenarios where we think it goes quicker. It might be possible, but that is not a route which I can guarantee. About 18 months from now, I see very, very high chances that we are ready to go and start to get revenue.
Next question is, will revenues be mainly derived from producing product or licensing plants to others?
Our first priority is to derive revenues from producing products, and that could be, at this moment, what we have lined up being the ethanol itself, the cellulosic ethanol, a biodiesel or biojet fuel derived from that ethanol was the second source. The third source is bioplastics, and we would probably start with throwaway items like straws, utensils, and all that stuff. So these three sources we are aiming for. Inside the U.S., we do not anticipate on giving licenses as a first priority. That does not say that I will exclude it, but most preferably we won't do it. Outside the U.S., it's a complete different story because we as a company wouldn't be able to serve the whole world. So depending on the situation and setup, it would be possible to sell licenses outside the U.S., but on very much arm's length and protecting our technology and looking at serious possibilities there. We wouldn't just go there and hunt that, go after that. Our first priority is to get our process up to commercial size and start generating revenues here in the USA.
Next question is, please highlight the advantages of the resulting Alliance lignin as it relates to pharmaceutical applications.
Well, that is a kind of a difficult question, and to be completely honest, we have not looked into our lignin for pharmaceutical applications yet. Having said that, I wouldn't exclude it, but we are working on the lowest hanging fruit, and that is not lignin for pharmaceutical applications at this moment. That would be lignin for plastics and sugars for ethanol, and subsequently perhaps the diesels and the jet fuels. So that is the closest by, and we would not enter into a whole new research area with the subsequent cost and time and effort to find out a market which might be there, which might not be there.
Next question is, where is Alliance in raising the tens of millions of dollars needed for the commercialization of the first plant?
Well, we don't need tens of millions of dollars to commercialize the first plant. We are well funded at this moment. We will raise some more funds until the development of commercial size is achieved. Then, if we would start producing ethanol in a ethanol factory with our technology, we would either build one or buy a factory and convert it, or make a joint venture with an existing factory. The money which we would need there would be purely a project finance, and we would look into that as a loan type of money, so that will not be equity in the mother. There will be an affiliate, which is a project which will separately financed, and perhaps even with loan guarantees from the USDA or DOE. We are looking into that and working on that in the background already. So that is how we will do that. And so to be honest, and how strange it may sound, I think that is not going to be a high barrier. It's going to be easier than raising equity as we have done up till now. And I think from now on, we will see that because we're a clean company, we have a clear-cut technology, and we are making clear progress, that further raising of money is going to be less complicated than it has been up till now. And we see that, and we see more and more interested parties in stepping into on the market itself, plus, having very high interest to invest in the company itself. So I think that is going to be a lesser and lesser concern going forward all the time.
And one more question is, are you planning another prototype before a commercial unit?
Yes, we will have another prototype between this one and a commercial size, which will be on semi-commercial size. I anticipate to be there in about 6 to 7, 8 months, depending on the building time and depending on how quickly we can realize and raise further development and improvement of the existing system. And after that, we will do testing again and then go to commercial scale. So that is the roadmap we intend to follow. So the answer is yes to that question.
So that's basically all the questions that we have time for today. Thank you for listening. And if you have any more questions, please feel free to email them to us, and we can answer them on a one-on-one basis. Thank you, everybody.
Absolutely. Thank you, Anthony. Thank you, everybody, for your time and interest, and wish you a good day.
Ladies and gentlemen, this does conclude today's webcast. Thank you for your participation. You may disconnect your line and have a wonderful